Today we start chapter number 4, Thermodynamics. It is related to temperature, heat, work, heat engine. Now let's see introduction of this chapter. Basically, what is thermodynamics? Thermodynamics is the branch of physics that deals with the concept of heat and temperature and the interconversion of heat and other form of energy. So this is related to heat and temperature. Means in this chapter we are talking about the concept related to the heat and energy only. Now here, according to the modern theory, heat is a form of energy. In 11 standard we have studied thermal properties of matter. In that chapter we learn related to heat and temperature. In this chapter we shall study the process where the work is converted into heat and vice versa, and the laws that govern these thermodynamics process. We will also study most important and useful applications of thermodynamics, the heat engine and their efficiency. First, a very important and the basic term of the thermodynamic is thermal equilibrium. What is thermal equilibrium? When we say that the bodies, two bodies are in thermal equilibrium, you can see here a diagram. So you can see hot body and cold body. When we keep these two bodies in touch with each other, then exchange of heat takes place. Heat is exchanged from hot, means heat is transferred from hot body to cold body, and this heat continues until both the body attain a constant temperature. We assume that heat is something that is transferred from a substance at higher temperature to that of lower temperature. This transfer continues till the level of heat contained in both the substances is same. You can see here the temperature of both the substances 26 degree. Then we say that thermal equilibrium is reached. When these two bodies attain same temperature, that time we can say that thermal equilibrium is reached. We can say that when two objects are at the same temperature, they are in thermal equilibrium. If two bodies having same temperature and they are in contact, then we can say that they are in thermal equilibrium. Thermal equilibrium means what? In short, we can write two systems in thermal contact with each other are in thermal equilibrium if they do not transfer heat between each other. If they are not exchanging heat, then they are called as thermal equilibrium. Now, next article is zeroth law of thermodynamics. If two systems are each in thermal equilibrium with third system, they are also in thermal equilibrium with each other. Now let I explain this statement with the help of one diagram. You can see this diagram here, the first diagram. So here you can see this body A and C. These two bodies are in thermal equilibrium with each other. At the same time, you can see here body A and B also in thermal equilibrium. Now here we can see A and C are in thermal equilibrium. A and B are also in thermal equilibrium. It means that B and C are also in thermal equilibrium. And this is zeroth law of thermodynamics. So you can see another diagram here. So if A and C, again here it is shown here, A and C, they are in thermal equilibrium. A and B also in thermal equilibrium. It means that B and C also in thermal equilibrium with each other. Now, The next we have to learn some basic concept: heat, internal energy, and work done. So what is heat? Everyone know what is heat. So you know that when we rub our palm together, it generate warmth. It generate heat. You know that why engine gets warmer. You know that two-wheeler engine, four-wheeler engine gets warmer when it is running. These means these are the simple examples here. Now in that examples, means in case of heat engine or when we rub our palm together, so heat, internal energy and work done. Related to that means related to the heat engine basically. In heat engine, heat is generated, some internal energy and work is done by using that heat engine. So these are the basic concept that we have to cover here. Now let me start with the internal energy. So internal energy is defined as the energy associated with the random disordered motion of the molecules of system. You can see here diagram. So here these molecules of the liquid, they are moving randomly, and energy associated with these random motion is called as internal energy. And internal energy is denoted by letter U. It is denoted by letter capital U. Now here you remember one thing. Internal energy is basically classified into two categories: potential energy and kinetic energy. Internal energy is because of potential energy and kinetic energy. Now here let me talk about a gas molecules, gas in a container. Now in that case, the gas molecules have only kinetic energy. The gas molecule have only kinetic energy, no potential energy. Now potential energy basically due to intermolecular forces and due to interatomic forces, because of the vibrational forces. When we are talking about gas molecules, it has only kinetic energy. The kinetic energy may be a translational kinetic energy, maybe rotational, or maybe vibrational kinetic energy. And in this kinetic theory of gases chapter, we already learned the relation between kinetic energy and temperature. So kinetic energy depends on the temperature. Kinetic energy depends on temperature. Now here, as well as you remember, at room temperature, internal energy of ideal gas is given by formula translational kinetic energy plus rotational kinetic energy. At room temperature, no vibrational kinetic energy. As well as the internal energy depends on the temperature. You know that kinetic energy proportional to temperature. So obviously here internal energy depends on the temperature. As kinetic energy increases, obviously internal energy increases, and kinetic energy increases when temperature increases. So here internal energy of ideal gas depends only on its absolute temperature T. So we are written here U proportional to T. Thermodynamic system and thermodynamic process. Thermodynamic system is collection of or a group of objects that can form a unit which may have ability to exchange energy with surrounding. Now we consider some example. Let me talk about a system. This is a boundary and this is a system. Okay, the system may be anything. Maybe water in a glass is a system. Okay, system may be anything here. And this is surrounding and this is a boundary. For example, here I consider here water kept in a vessel is a system. So when we are talking about this is a vessel and water is in a vessel, it is a system. Vessel is its boundary, and atmosphere around it is a surrounding. Now, thermodynamic system. We classify the thermodynamic system into three categories. The first one is open system, closed system, and third one is isolated system. Now, what is open system? So, open system means the system, the system here which allow exchange of energy and matter. You can see here. Energy means maybe heat energy, which allow exchange of and heat energy and matter. That system is open system. Now closed system. The system which allow only exchange of energy but does not allow the exchange of matter. Does not allow the exchange of matter. That system is closed system. Third one is isolated system. You can see in a diagram isolated system. The system cannot exchange matter as well as heat with its environment. That system is isolated system. Now next article is heat. Let us now try to understand heat and its relation with internal energy. Consider a glass filled with water on a table. Now I consider here Ts, temperature of this system, means temperature of the water basically. Te, temperature of environment. Q, energy transferred between the system and its environment. We notice that if Ts and Te are not same, then thermal equilibrium will be reached. We already learned thermal equilibrium. In that we learn heat is transfer from hot body to cold body. If the temperatures are not same, then heat exchange will be there between the system and surrounding. Ts is the temperature of the system and Te, E for environment, temperature of the environment. Transfer between system and its environment occur. Now let's see some cases here. Case 1. If Ts less than Te, temperature of system is less than the temperature of environment, then system gain energy and Q is positive. System gains some energy and Q is positive. So here system gain energy and Q is positive. You know that heat is flowing from hotter body to colder body. Now here environment is hotter and system is cold body. Temperature is less, that's why. So here heat is transfer from environment to system. So system gain energy and therefore Q is positive. Now let's see next case. Case number 2. If Ts is greater than T, Ts temperature of system is greater than the temperature of environment, then the energy flow from system to environment. This is environment. System loses energy and therefore the energy of the system start decreasing, and here Q is negative. Q is the energy transferred. Q is negative. Now the case number 3, if Ts is equal to Te, means temperature of the system and the temperature of environment both are same, then you remember here no transfer of energy. If no transfer of energy, then Q is 0. Then here Q is 0. So remember when Q is positive, Q is negative, and Q is 0. Three cases we learn. When heat is flowing from environment to system, in system gain energy, and Q is positive. Now next case, case number 2. When heat is flowing from system to environment, the system loses energy. System loses energy means the Q is negative. When system and environment having a same temperature, then there will be no transfer of energy between system and environment. So Q is G. Now we have to remember this point. When transfer of energy takes place between system and surrounding or environment, we observe the following convention. When energy is transferred to system from environment, energy is positive. And system gains some energy. System gain energy. Means energy is positive. And the second one is when energy is transferred from system to environment, system loses energy, so energy is negative. Next article we have to start it is change in internal energy of system. When internal energy of the system changes, that we have to learn. So we consider here the two ways to change the internal energy. First way is by heating it, and second way is by doing work. If we heat the object, internal energy changes. Or if we do some work on the system, then also internal energy changes. Now we consider both the ways one by one. So the first way is change in internal energy of system by heating. The cylinder can be brought in contact with source of heat. Now let me heat cylinder and we observe how the internal energy changes. You can see in a diagram here. See this diagram. So this is cylinder. So it is at 100 degrees Celsius. When we start heating by burner, then temperature changes to 200 degrees Celsius. This is the final state. This is the initial state and this is final state. Now when? So this we already covered here. When temperature of environment greater than the system, then there will be increase in internal energy of gas. Such exchange of energy is possible in another way also. If the surrounding is at temperature lower than the gas, when Ts is temperature of system greater than the temperature of environment, then gas will lose energy to its environment and cool down. The change in internal energy of system by doing work. When we quickly push the piston inside the cylinder so that gas is compressed as shown in figure. Now here you can see diagram. We push this piston with some force F, then gas is compressed. When gas is compressed, that time you can see here. So in initial state temperature is 100 degrees Celsius. When we push the piston, then it compresses and the temperature is 200 degrees Celsius. Means temperature increased. Temperature increased means obviously internal energy increased. Means we can change internal energy by doing work also. Because here, when we push the piston, some work is done on the gas. Some work is done on the gas. And when the work is done, internal energy changes. When piston moves inside through some distance, gas gain energy and its temperature increased. You can see difference in the temperature in a diagram also. So temperature initially is 100 and when it is compressed 200. Means temperature increased by 100 degrees Celsius. On the other hand, if gas pushes the piston out. So reverse to this. So here we push the piston in. Now here, if gas pushes the piston out so that expand gas expand. Again some work is done here. Now here the work is done by the gas. In first case, work is done on the gas. Opposite to that, work is done by gas. It loses some energy and gas cool down. Work done on system. When we do some work on the system and the change in internal energy of the system, it changes the internal energy. Means we can change internal energy by two ways. The first one is by hitting it or by doing work. And this leads us the first law of thermodynamics. And this leads first law of thermodynamics.